everyone. So this is our last part of wet chemical synthesis, which is combustion synthesis. Right. Combustion synthesis or fire synthesis is also known as self-propagating high temperature synthesis. So the term combustion here refers to flaming in gas phase or smoldering in solid gas phase, and also explosive reactions. To generate fire, we need oxidizers, temperature, and fuel. This triangle is what we call the fire triangle. Combustion synthesis is highly exothermic redox reaction between an oxidizer and fuel. Redox reaction involves simultaneous oxidation and reduction process. This is the general flowchart for the preparation of oxide materials by combustion synthesis. So, we need metal nitrates, which act as the oxidizer and fuel agent. So we have to mix this in stoichiometry and then add water to form the aqueous redox mixture, followed by combustion, and finally we will get ash useful oxide. Properties of combusted powders like crystallite size, particle size, morphology, purity, phase, and degree of agglomeration are usually controlled by nature of fuel, whether we use soft fuel or aggressive fuel, okay, and ratio of fuel to oxidizer, and also initial furnace temperature. Various fuels have been used in combustion synthesis, powders such as glycine, citric acid, and urea. So each fuel differs in reducing power, the combustion temperature, and amount of gases they generate. Fuel play an important role in combustion synthesis. Okay, without fuel, there's no combustion. So fuel serve as the source of carbon and hydrogen, which on combustion form simple gaseous molecules, such as CO2. They form complex with the metal ions, facilitating homogeneous mixing of cations in solution, and fuel also will break down into components from which they form. These components in turn decompose to produce combustible gas. There are 6 important criteria of fuel that we have to consider, and these will make the fuel as ideal fuel. Okay, so the fuel must be water soluble. It has to be compatible with the metal nitrates, and it must have low ignition temperature, preferable less than 500 degrees C, because we don't want to combustion at high temperature, let's say 1000 degrees C, for example, that might cause explosion or fire. Okay, so we prefer to use low ignition temperature fuel. So the fuel should also involve large amount of gases that are of low molecular weight and harmless during combustion. The yield of this fuel should be only oxide. Okay, and finally, the fuel should be readily available or easy to prepare. This is example of synthesis of bismuth titanate by combustion method. So you need bismuth solution, titanium solution, and citric acid. So these are your oxidizers, and this is the fuel. So the first thing is hydrolysis at about 40 to 60 degrees C, followed by dehydration at about 80 degrees C to form a sticky gel. So this sticky gel we will then combust at about 200 degrees C. So meaning that from 80 degrees C, once it forms sticky gel, we will increase the temperature up to 200 degrees C to form the combusted powder. But commonly, this combusted powder is um, has a secondary phase or is not pure because the reaction is incomplete. So what we need to do, we have to do calcination to ensure the powder reaction is completed. Okay, so finally we will get ascalcine bit powder, and we have to characterize to make sure they are pure, they are single phase, they are fine powders, all criteria to meet the advanced ceramic powders. Okay, and finally, the advantages of combustion synthesis. It is very simple preparation. It can produce high purity powders with variety of any size and shape of the powders that we want, and it also has good stability of metastable phase. Okay, so that's all for soft combustion synthesis, and with that we end our wet chemical synthesis lectures. Thank you.